Option Greek, Vega. Vega is the sensitivity of option price in response to change in the volatility of the underlying asset. Therefore, we can express Vega as follows. It's a change in option price relative to the change in volatility of the underlying asset. And what I always like to do with a ratio, which has a numerator and denominator, is I like to take the ratio and flatten it out, which is exactly what I've done over here. So change in option price is equal to Vega times the volatility or change in volatility of the underlying asset. Now for both calls and puts, Vega is positive, meaning that as volatility increases, and because Vega is positive, it would mean that the value of the options would increase as well. And here's the framework. As volatility increases, the potential for higher payoff increases, so the upside gets even bigger. But the thing with options is that the downside payoff is always limited to 0, so it can't fall below 0. So if the option expires out of the money, that's it, you just don't exercise and you walk away with 0 payoff. But the upside can be even higher as volatility increases. And let's illustrate that with an example, because that's the best way to understand the impact of volatility on option price. Suppose that the price of the underlying asset is $100 and the strike price of the option itself is $100 as well. Now in the first scenario, we're assuming that volatility is $10, meaning that they can either go up $10 to $110 or drop to $90, which is a loss of $10. So let's calculate what the payoffs would be first for a call option. Remember, the strike price is 100. So if it's trading at 110, you have the right to buy it at 100. You make $10. But if the price drops to 90, well, I'm not going to exercise this. In other words, I'm not going to pay $100 to buy an asset that's worth 90. So the payoff would be 0. Now let's do it for a put option. Again, remember, strike is 100. If the price goes to 110, well, I'm not going to sell an asset that's worth 110 for only 100, so the payoff is 0. On the other hand, if the spot price goes to 90, yes, I will sell it for 100 and walk away with $10. So what happened here? In the first scenario where volatility was 10, what were the payoff potentials? We either made $10 or we made 0, and that's exactly what we have. But now let's see what happens as volatility increases to $40. So the price can go from 100 to 140, and so in the case of a call option, you would make $40 because here's an asset that's worth 140. You only have to pay 100 for it, so you make 40. On the other hand, it could drop 40, so it could go from 100 to 60. Well, let's see here. I'm not going to pay $100 in order to buy $60 assets, so the payoff would be 0. How about for a put option? Well, if the price goes up to 140, I'm not going to sell it for $100, so the payoff would be 0. On the other hand, if the price drops to $60, which is a loss of 40, then I'll gladly deliver a $60 asset in order to get $100. So I walk away with $40. So let's do a summary. What was the payoff under this scenario? Well, you could see that doesn't matter which option you're looking at, the maximum or the upside went up to 40, but the downside stayed at 0. And there it is, ladies and gentlemen, there it is. Let's make the connection. As volatility increased, what happened to, first of all, your downside? Nothing. It stayed 0. But what happened to your upside? It increased. So therefore, that's why the value of both options would increase as volatility increases. Now for the underlying asset itself, or the forward on the underlying asset, Vega is 0. And that's because volatility only affects instruments that have an asymmetric payoff. Like this, only options have asymmetric payoffs. So that's why volatility affects option value. But with spot or the underlying asset or the forward, it has a one-to-one relationship. In other words, it's got a symmetric payoff profile, and therefore the volatility will not affect its valuation.